The truth is, I wasn't going to upload videos this week. I had already told the guys in the Premium Members WhatsApp group, because I've been kind of tired and wasn't in the mood. But on Thursday, I woke up feeling better and started playing around with some old tubes I had here, and I ended up feeling better. A very simple regenerative receiver, which I'm sure more than one of you will find interesting. A while ago, I had already shown this circuit in a video, but now I decided to make it more presentable, get it all nicely set up, and explain how it works. Today we're going to thoroughly analyze the operation of one of the most iconic circuits from old-time radio, the regenerative receiver. I've put together this version. Look how nice everything turned out here. Using a 6H-5 pentode, it's a small miniature tube. This little tube is very, very interesting. It's a pentode. And, well, let's break down how a handful of components manages to extract radio signals from the air and amplify them thousands of times. Notice how simple it is. It's really simple. It has very few components. I'll give you the list of materials, but there are just a few things. To assemble the receiver, well, the main thing is to get a vacuum tube. There are many tubes you can use for this project. It could be a 12AU-6, a 6AU-6, a 6H-5, or some other pentodes out there. Well, we're also going to need a variable capacitor, one of those tandem types, a 30 picofarad capacitor, a 100 picofarad capacitor, and a 10 nanofarad capacitor. We're also going to need a 1 megohm resistor, a 32 ohm 2 watt resistor, to adapt the filament of the 6H-5, since I'm going to power the whole assembly. With 12 volts including the plate, so there's no high voltage. You can even do it with lithium batteries. But you have to adapt it, because the filament of this tube, the 6H-5, works with 6.3 volts. So you need to add a resistor in series to avoid wearing out the filament prematurely. We will also need a 10,000 ohm potentiometer and a transformer from 220 to 12 volts. We're not going to use it connected to 220. We're just going to use it as an audio transformer. The coil is made on a PVC pipe with a diameter of 20 millimeters, using wire with a diameter of 0.3 millimeters. First you wind 10 turns, then make a tap there, and then wind 100 more turns. In total, it would be 110 turns with a tap at 10 turns. The 6H-5 is a pentode. It has additional grids that help reduce internal capacitance. It's better than a triode. Originally, these receivers were made with triodes, but this pentode is even better than the triodes. An important detail, the way I mounted the tube, is what I was just telling you about, which requires 6.3 volts in the filament. And well, since I'm going to power it with 12 volts, I installed a resistor in series. Here you can see it in the schematic to drop the exact voltage and not wear it out. It's calculated like this. It's the 12 volts minus the 6.3 that I need for the tube that gives us a difference of 5.7 volts, which is what needs to drop across the resistor. The filament current, which is what gives us that. The tube's data sheet says it's 0.175 amperes. And well, now by Ohm's law, 5.7 divided by 0.175 amperes gives me the value of the resistance. A resistor of around 32 ohms with a power rating of about 1 watty. If we multiply 0.175 by 5.7, we get 1 watt, but it's better to use a 2-watt one just in case. And, well, that's going to dissipate the excess voltage so the filament works happily and doesn't overheat. Let's explain how it works. Everything starts here, in this coil you see here in the circuit, and here in the same radio that I built. The coil and the variable capacitor form a tank circuit. Together, they determine. With the signal coming from the antenna, the resonance frequency, the signal traveling through space, introduces a minimal current into that coil. And it selects only the station we want to listen to. That is, as we move the capacitor, we listen to different stations. Because it keeps selecting, that tank circuit goes into resonance, and it generates that small current. To listen to the audio, that needs to be detected. Well, the radio frequency signal, the one that's there in that coil in that tank, it goes through this resistor capacitor network connected to the grid of the tube, and that functions as a detector. The tube not only amplifies, but also rectifies the signal so we can extract the speech or music. But, well, look here is the heart of the matter. This is where the circuit gets interesting, and it differs from other designs. Notice that the cathode of the 6AK5 doesn't go directly to ground, but instead connects to an intermediate tap on the tuning coil. As the current from the tube flows through that small section of the coil, energy is induced that reinforces the original oscillation of the tank circuit. It's positive feedback by cathode coupling. It's similar to what a Hartley oscillator is. That feedback, of course, has a limit, because if we keep pushing it, we'll end up making the tube oscillate. So you have to set a limit. So if we feed back too much energy, the circuit becomes an oscillator and stops receiving clearly. That's why a regeneration control is used by varying the screen voltage, which is this one right here. It's a potentiometer. As you can see, it's between the plus 12 and ground. Well, the sweet spot, let's say where the station sounds good, is just before the circuit starts to squeal or whistle. Notice that as you turn the potentiometer, you'll see the signal increases a lot. It gets louder and louder, but there comes a point when it starts to whistle, and that's when we need to turn it down a bit, because that's the sweet spot where we'll hear the stations. The receiver, look, I've got it running here. So that you can hear it well, I've connected an amplifier, but this is usually used with an earphone. You can use a regular headphone, like the ones used in radios, any kind. It's not a high impedance earphone. It's a regular earphone. It's connected to the transformer secondary. It's amazing that technology from almost a century ago is still so efficient, isn't it? We have a receiver capable of picking up stations from thousands of kilometers away. Listen to how Radio Continental comes in here. It's a little over 500 kilometers from Buenos Aires. So look at how it's coming in. Really strong. Soon I'm going to make another regenerative receiver, but this time I'm going to do it using a field effect transistor, which basically works very similarly to a vacuum tube. If you like tube electronics and pure tinkering, well, this is a must-do project. It would have been good to put this project on the radio channel, but since I didn't have the time and wasn't feeling very well, I'm going to put it on the main channel. Don't forget to like and subscribe, and if you're a big fan, you can join and support the channel. In that case, I'll add you to a WhatsApp group where the premium members are. Thank you so much for watching the video, and see you next time, God willing.